Today, we're diving into a really fascinating scientific paper, one that presents a way to move that could, honestly, change everything we think we know. It sounds like something straight out of science fiction, but the ideas here, they're grounded in some very real and, frankly, very clever physics.
It's one of the first things we all learn in science class, right? To move forward, you've got to push something backward. It doesn't matter if you're walking on the ground, a car's tires are pushing on the road, or a boat is pushing through the water. It's always the same basic idea.
And there it is, Newton's third law of motion. This is the entire foundation for propulsion as we know it, from our own 2 feet all the way up to the most powerful rockets that launch us into space. They all work by throwing mass out the back to go forward. Okay, but this paper we're looking at asks a really wild question. What if you could move without pushing against anything? What if you could actually generate motion just by using energy, all contained within the object itself?
So, where do we find the answer? Well, according to these researchers, it's hidden deep, deep inside matter, at the atomic level. And the key to unlocking it is a well known scientific principle called nuclear magnetic resonance, or NMR for short.
Now, don't let that name scare you off. The concept itself is actually pretty beautiful. See, certain atomic nuclei, the very heart of atoms, act like incredibly tiny spinning magnets. NMR is basically just the science of how we can watch and control these little spinning tops. So picture this, you take a material and you stick it in a really strong magnetic field. All of a sudden, these little nuclear magnets, they just kind of snap into alignment. They stop pointing every which way and they mostly line up with the field, all facing the same direction. And check this out. Even while they're all lined up, they're also doing this little wobble or precessing. Just think of a spinning top right before it's about to fall over. Now this is crucial. Every single one of those wobbles carries its own tiny little bit of rotational energy, its own angular momentum. And this is where the magic happens. We can actually control them. You can fire a specific radio wave, an RF pulse, at these wobbling nuclei. And if you get that timing absolutely perfect, this pulse acts like a little kick, forcing them all to change their orientation and their energy state at the exact same time. Okay, so we can control the spin of tiny nuclei. Big deal, right? How in the world does that lead to movement? Well, it all comes down to another fundamental law of the universe, the conservation of angular momentum. Think of an ice skater. When she pulls her arms in, she spins faster, right? The universe is always trying to balance its books. And that is the key. This here perfectly lays out the core idea. So in a normal stationary object, you've got trillions of these wobbling nuclei all moving in random directions. Their individual little spins completely cancel each other out. The grand total is zero. But what if that RF pulse we talked about could make them all change their spin in the same direction at the same time? Suddenly, they wouldn't cancel anymore. They would all add up. And there it is. That's the light bulb moment. If the system started at zero angular momentum, it has to stay at zero. So if all those tiny nuclei suddenly gain a collective spin in one direction, the entire object has no choice but to rotate in the opposite direction to perfectly balance things out. The universe literally demands it. An incredible theory, for sure. But is it just that? A theory? No. The paper gets into a specific experiment they designed to test it. And for this, they chose a material called bismuth, mostly because its unique crystal structure makes its atomic nuclei really responsive to this kind of magnetic poking and prodding. The procedure itself looks pretty straightforward, on paper anyway. First, they put that bismuth disk inside a strong magnetic field. That gets all the nuclei lined up, just like the theory says. Then, and this part's pretty clever, they hit it with an electrostatic charge, which kind of sensitizes the material, makes it more ready for what's next. And then finally, bam, they hit it with that perfectly timed radio frequency pulse to get all those nuclei to flip their spins together. And here is the actual schematic from the paper, showing the whole setup. You can see the bismuth disk sitting right there between the north and south poles of the magnet, all ready for the test. Seeing it like this makes it all feel very real, doesn't it? So the million-dollar question, did it work? Well, this is a direct quote from the paper's results. And the answer is yes. They saw that when the RF pulse hit the disk, it physically moved. It made a partial rotation. It turned all by itself without anything pushing it. A small turn in a lab might not seem like a huge deal, But let's just stop and think about the implications here, because they are absolutely staggering. If you can turn energy directly into motion, what does that really mean for the future?
The authors of this paper, they do not hold back in their conclusions. They state, flat out, that they've shown a way to turn RF energy directly into work, that you can move without throwing mass out the back, which would be a total game changer for space travel. They even suggest it might be possible to use natural magnetic fields, like the Earth's or even the Sun's, to power a spacecraft.
Just let that sink in for a second. No massive fuel tanks, no chemical rockets, just a source of energy applied in a really smart way to create movement. I mean, that is a fundamental shift in how we even think about getting from point A to point B. So we've just walked through a mechanism that seems to break our everyday rules, but it's built on the solid bedrock of physics. And it leaves us with this truly mind-bending question to chew on. Could this little spinning disk in a lab be the tiny seed of something that one day takes humanity beyond our solar system? Wow, what an incredible thought.